The grand solar minimum, GSM, is a period of decreased solar activity that can have significant impacts on Earth's climate and society. The Sun goes through a regular cycle of activity known as the solar cycle, which lasts around 11 years on average. During this cycle, the Sun's magnetic field becomes more or less active, resulting in changes in the number of sunspots and solar flares. The GSM is a phenomenon that occurs when solar activity reaches an unusually low level during a solar cycle, resulting in a significant decrease in solar radiation reaching the Earth. Understanding the GSM and its potential impacts is important for predicting and preparing for shifts in Earth's climate and for mitigating any negative consequences that may arise. The solar cycle is driven by the Sun's magnetic field, which becomes more active as it approaches solar maximum and less active as it approaches solar minimum. Solar maximum is characterized by an increased number of sunspots and solar flares, while solar minimum is characterized by a decrease in these features. The GSM occurs when solar activity reaches an unusually low level during a solar cycle, resulting in a significant decrease in solar radiation reaching the Earth. This decrease in solar radiation can have a range of impacts on Earth's climate, including changes in temperature, precipitation, and extreme weather events. There is evidence that the current solar cycle, known as solar cycle 25, may be heading towards a GSM. Some scientists predict that solar cycle 25 will be weaker than previous cycles, with a longer and deeper solar minimum. This prediction is based on a variety of factors, including the observed decline in solar activity and the increase in cosmic rays reaching the Earth. Cosmic rays are high-energy particles that are thought to be influenced by the Sun's magnetic field, and an increase in cosmic rays is often seen as a sign of a GSM. The causes of the GSM are not fully understood, but there are several theories that have been proposed. One theory suggests that the GSM may be caused by changes in the Sun's magnetic field, which can affect the number and intensity of sunspots and solar flares. Another theory suggests that the GSM may be influenced by the gravitational effects of other celestial bodies, such as Jupiter and Saturn. Some research has also suggested that the GSM may be related to the Sun's internal dynamics, such as the movement of plasma within the Sun. There is also evidence that GSMs have occurred in the past. The most well-known GSM is the Maunder minimum, which occurred in the 17th and 18th centuries and is thought to have contributed to the Little Ice Age in Europe. The Maunder minimum was characterized by a significant decrease in solar activity and an increase in cosmic rays, similar to what is being predicted for the current solar cycle. Other GSMs have been identified in the past, although the evidence is not as clear as for the Maunder minimum. In summary, the GSM is a period of decreased solar activity that can have significant impacts on Earth's climate and society. The current solar cycle, solar cycle 25, may be heading towards a GSM, which could result in a range of impacts on Earth's climate and society. While the causes of the GSM are not fully understood, several theories have been proposed, and there is evidence that GSMs have occurred in the past. Understanding the GSM and its potential impacts is important for predicting and preparing for shifts in Earth's climate and for mitigating any negative consequences that may arise.